In our last lecture, we explored one of the most important topics in Python, strings. We learned what strings are, how to access characters using indexing, how to extract parts of strings using slicing, and how to use different string methods. We also learned about escape characters and modern string formatting using f-strings. But up to this point, every program we wrote followed a very simple pattern. Python started from the first line of code and executed every statement one after another until the program ended. But let me ask you a simple question. Can every real world problem be solved by simply executing every line one after another? The answer is no. Think about the application we use every day. When we log in into Instagram, the app checks whether your username and password are correct. If they are correct, you are logged in, otherwise it shows an error message. These applications don't execute same action for every user. They make decisions based on different situations. Today we will learn how to make our Python programs do exactly the same thing, which is decision making. Before learning the syntax, let's first understand what term decision making actually means. As we humans, we make hundreds of decisions every day. For example, there is raining outside. And I want to make a decision if I should carry umbrella or not. So I should carry umbrella or not. For that I have two options, yes, no. So here I am making a decision. Similarly, take example of a student's result. For example, if a student got marks greater than 40, then he or she shall pass. So here is a decision, pass or fail. Computers are very similar. A computer cannot think on its own, it only follows the instructions we give it. If we want a computer to make decisions, we must tell it what conditions to check and what actions to take. For a computer-based system, firstly we will define a condition. Then we check if the condition is true or is false. And after checking this true and false value, we will make the decision. And then we will execute the code. So now, what is a condition actually? So condition is simply a question whose answer can only be one of the two possibilities, whether it is true or whether it is false. If you can recall, we learned about Boolean values in the previous lecture. This is exactly the same thing. Today we will finally see why Boolean values are so important. Every decision in Python is based on these two values. First, for decision making, we first start the program, then we check the condition. Then we see if the condition is true. If the condition is true, we will execute the code. And if the condition is a false value, then we will skip or execute the other code. This is the very basic flow of decision making in Python. Every time Python reaches a decision point, it first checks the condition. If the condition is true, it executes one block of the code, and if the condition is false, it skips the block or executes another block. So by the end of today's lecture, we will be able to write programs that can make decisions just like real world applications. Before a program can make a decision, it first needs way to compare values. How does Python know whether one number is greater than another? How does it check if two values are equal or determine whether something is true or false? To answer these questions, we first need to learn comparison operators, which are the building blocks of decision making. So let's move to the next part of today's lecture and explore comparison operators in Python. In the previous part, we learned that every decision in programming is based on a condition. But here's an important question. How does Python actually check a condition? For example, how does Python know 10 is greater than 5? How does it check whether two numbers are equal or not? To answer these questions, Python provides us with comparison operators. These operators compare two values and always return one of the two results, true or false. So comparison operators are special characters or special operators used to compare two values. Remember, comparison operators never return text or number. It always returns Boolean values. That is whether it is true or false. For example, suppose Rahul got 80 marks and Aman got 80 marks as well. So are Rahul's marks equals to Aman's marks? Yes, 80 is equals to 80. So this is true. Now if Rohan got 65 marks, so are Rahul's marks equals to Rohan's mark? 80 is equals to 65. This is a false statement. This is exactly what comparison operators do. They compare values and tell Python whether the comparison is true or false. So now we will be looking at these comparison operators one by one. Starting with the very first operator which we have is equals to, which is represented by double equal to sign in Python. The double equal to sign checks whether the two values are exactly the same. If the both values are equal, Python returns true. For example, is 10 is equals to 10 true? This is a true statement. Is 10 equals to 20? This is a false statement. Similarly, we can use string values also. Is Python is equals to Python? This is true. Or we can say is Python is equals to Java. So this will return a false value. So the thing here you need to understand here is there is a difference between this equals to and this equals to. This one equal to sign is used to assign the values, and this double equals to sign is used to compare the values. For example, if I write a equals to 10, then what I am doing, I am creating a variable named a and I am storing the value 10 in this. But if I write a is equals to 10, then Python will return me an error because here I am comparing values rather than assigning one. Now moving to the next operator, which is not equals to. So the not equals to operator is exactly opposite of equals to operator, and it is represented by this sign. This is how we represent a not equals to operator. For example, if I write 10 is not equals to 5, so this will return me a true value. And if I write 10 is not equals to 10, this will return me a false value. This operator checks whether two values are different. If they are different, the result is true. If they are same, the result is false. The next operator which we have is greater than. Greater than operator is represented by this sign. For example, if I write 20 is greater than 10, this is a true statement. And if I write 5 is greater than 10, this is a false statement. The greater than operator checks whether the value of on the left hand side is larger than the value on the right hand side, and exactly opposite to the greater than operator we have less than operator, which is represented by this. This works exactly opposite to the greater than operator. If I write 20 is less than 10, this will return me false. And if I write 5 is less than 10, this will return me true. Then we have greater than or equals to operator. Which is represented by greater than sign, and after that we write this equals to sign. So what does this greater than equals to operator is different from greater than operator. For example, if I write 18 is greater than 18, this will return me a false value. But if I write 18 is greater than and or equals to 18, then this will return me a true value. This operator returns true if the left value is either greater than or equal to the right value. Similar to this, we also have less than or equals to operator. Which is represented by this sign. For example, if I write 10 is less than equals to 20, so this is a true statement. And if I write 20 is less than equals to 20, this is a true statement as well. This operator turns true if the left value is either smaller than or equals to the right value. Now we know how to compare values and get a result of true and false. But comparing value alone isn't very useful unless we can make decisions based on those results. In the next part, we will run if statement, which allows Python to execute code only when condition is true. In the previous part, we learned how Python compares values using comparison operators. We saw that every comparison returns either true or false value. But let me ask you a very important question. What should Python do after it gets a true or false result? Imagine I ask Python, is the student's age greater than or equal to 18? Python checks the condition gets either true or false, but checking alone isn't enough. We also need to tell Python what action to perform if the condition is true. That's exactly why we use if statement. So if statement returns or executes a block of code only if the given condition is true. Now I will tell you about the syntax of if statement. So firstly, what we do, we write if, and after if we define our condition, and then we write a semicolon, and in the next line we write our statement. So this is how we write if statements in Python codes. The keyword if tells Python what we are about to check that we are about to check a condition. This is the comparison that evaluates the true or false, and this semicolon. The colon tells Python that the block of code is about to begin. Forgetting the colon is one of the biggest beginner mistakes. And this space here is called indented, line. Indentation means leaving some space before the code. In Python, indentation is not optional. It tells Python which statements belongs to if block. For example, now we are going to look at some examples which we will solve using if statements. Example 1. Voting eligibility. Suppose the government wants to check whether someone can vote or not. The rule is simple. If the person's age is greater than 18, they are eligible to vote, otherwise they are not. So this is a perfect example of if statement. For that, what we will write if age is greater than equals to 18, then we will print person is eligible to vote. Moving to the next example, which is positive number. So if the number entered by the user is greater than 0, the Python prints positive number. For that, we will write if n, which is our number, is greater than 0, then print positive. Can you notice this space before the print statement? Python uses indentation to determine which statement belong to if block. For example, if I write this code in this way, if age greater than 18, print eligible. So this if statement is completely incorrect because print statement is not indented. Python will raise an indentation error. By convention, Python programmers use 4 spaces for one level of indentation. Most editors like VS Code and Jupyter Notebook insert this automatically when you press the tab key. The if statement is useful when we want to perform an action only if condition is true. But if we also want to specify what should happen if the condition is false. For example, if a student doesn't pass, we don't want the program to stay silent. We want it to display fail. To handle both situations, Python provides the if-else statement also. We will learn in the next part. In the previous part, we learned about if statement. We saw that Python executes the code inside the if block only when the condition is true. But let's think of something else. Imagine you are checking whether a student has passed an exam or not. If the marks are greater than or equal to 40, the student has passed. But what if the student scores only 25 marks? Should the program simply do nothing? Of course not. It should display fail. This is where the else statement becomes useful. So if we look at the definition of if-else statement, it says if-else statement allows the program to choose between different blocks of code based on whether the condition is true or false. If we look at the syntax of if-else statement, it's written like this. Firstly, we will write the if statement, then we will define our condition, and we say if this condition is true, execute statement 1, else execute statement 2. Python first checks the condition then comparison returns either true or false. If the condition is true, Python execute this block, and if the condition is false, Python skips this whole if block and execute statement 2. Execute. So the important point to be noted is only one block is executed. Python never executes both if block and else block in the same decision. So the flow of program looks like, firstly we will start the program. After that we will check the condition. If the condition is true, if block is executed, and if the condition is false, else block is executed, and after that the program ends. Now let's look at some examples of if-else statement. The first and traditional example that we have is pass or fail. So if the marks are greater than equals to 40, this is one of the most common examples of decision making. If the student marks are 40 or more, then we display pass, else we display fail. Notice that no matter what marks are, one of the messages will always be displayed. The next example that we have is odd and even. We have learned about the modulus operator. To check whether a number is odd or even, we use the modulus operator here. For example, I am given a number, and if the modulus of the number with 2 is equals to 0, then the number is even. And if this statement is not true, which is n modulus 2 is not equals to 0, then it's an odd number. The modulus operator gives us the remainder after division. If a number leaves a remainder 0 when divided by 2, it's an even number, otherwise it's an odd number. Now we will quickly look at the difference between if and if-else statement. So the if statement handles only true values, while else if statements handles both true and false values. If statement may execute nothing if the condition is false. While the if-else statement always executes one block. So far we have learned how to make a decision between two possibilities, true and false. But in many real world problems we have more than two possibilities. To solve such problems, Python provides the elif statement, which allows us to check multiple conditions. In the next part, we will learn how to use an elif statement and also explore nested if statements. So in the previous part, we learned about if-else statement. It works perfectly when there are only two possible outcomes. For example, pass or fail, even or odd. But let me ask you a simple question. What if there are 3, 4 or even 10 possible outcomes? Can we handle that using if or else? The answer is no. That's why Python provides another keyword called elif. For example, I am creating a grading system for a school, and I say if a student gets 90 plus marks, he or she will get A grade. If 75 plus, then B, 60 plus C, 40 plus D, and then fail. There aren't only two outcomes. A student can receive grade A, B, C, D or fail. Since there are multiple possibilities, that's why we use elif statement. So if we look at the definition of elif statement, the elif statement allows Python to check multiple conditions. Python checks the conditions from top to bottom. As soon as one condition becomes true, Python executes the block and ignores all the other conditions. If we look at the syntax of elif statement, firstly we will write our if statement, we will define our condition, and if this condition is true, execute statement 1. Elif condition 2 is true, run statement number 2. Elif, we can add as many elif statements as we want. If this statement 3 is true, execute this, and lastly else, if none of them are true, execute statement number 4. So the Python starts with the if statement. If it is true, the block runs and the rest are skipped. If it is false, Python checks the first elif. If that is also false, it checks the next elif. Finally, if none of the conditions are true, the else block executes. If we look at the flow of program, we will see firstly we started, then check condition number 1. So there are two possibilities for that. Either the condition is true or it is false. So if the condition is true, we execute statement 1. And if it is false, then what we will do, we will move to the another statement. We will check condition number 2. Then again we have two possibilities, true, false. If true, execute statement 2. And if it is false, then it will move to the another block of code, which is condition number 3. Then it checks condition 3. Again, two possibilities. If true, execute statement number 3. And if false, then we will move to another statement, which is else statement. Then statement 4 is executed. Now let's look at some examples of elif statements. Firstly, we have the grading system. Example number 1, that is grading system. Say marks are greater than equals to 90. Then return grade A. Marks are greater than equals to 75. Return grade B. Marks are greater than and equal to 60. Then return grade C. And or else return fail. Python first checks whether the marks are 90 or above. If yes, grade A is assigned. If not, Python checks whether the marks are at least 75. If yes, grade B is assigned. Otherwise, it continues checking to the remaining conditions. Now moving to our next topic, which is nested if. Sometimes one decision depends on another decision. In such cases, we place one if statement inside the another if statement. This is called nested if statement. A nested if statement is an if statement written inside another if statement. For example, we have a condition 1. If the condition 1 is true, then we will check for condition number 2. And if the condition 2 is also true, then we will return our action. So the second condition is checked only if the first condition is true. Today we have learned how Python makes decisions. We started with comparison operators, then we used if to execute code within when the condition is true, if else to handle two possible outcomes, elif for multiple choices, and finally nested if for situations where one decision depends on another. That we have completed the theory of comparison operators. Now it's time to see how they work in Python. In this section, we will write simple programs and observe the outputs. As you watch, try to predict the result before we run each program. This is a great way to improve your programming skills. First of all, but for the first program of the day, what we will do in the print statement, I will try to cover each and every operator one by one. Firstly, we will look at the equals to operator. So if I write 10 is equals to 10, and if I run this program, it will return true because 10 is equals to 10 is a true statement. We can also do 50. If I write 15 is equals to 20, this will return false because this is the first statement. We can also compare strings using the comparison operators. For example, if I write Python is equals to Python. Since both of the strings are similar, it will return true. And if I write Python is equals to Java, then it will return me false. Okay, so this was the equals to operator. The next operator which we have is not equals to operator. For that, if I write 10, this is how we use not equals to operator. 10 is not equals to 10. Shift plus enter, this will give me false. Because 10 is equals to 10 is a true statement. But here I write 10 is not equals to 10, which is a false statement. If I write 15 is not equals to 20, this will return me true. And if I write for the strings as well, if I write say Python is not equals to Java, this will return true. Moving to the next operator, which is greater than operator. If I write 20 is greater than 10, and if I print 15 is greater than 20, the first statement is true and the second is false. So here we can see the result of the first statement is true and the second is false. Then we have the less than operator. Right, print 20 is less than 10. And if I write print 15 is less than 20. So the result of the first statement should be false and the second statement should be true. Here we can see we get the output which is false and true. Now the next operator which we have is greater than or equals to operator. If I write 10 is greater than 10, This will return me false statement. But if I write print 10 is greater than or equals to 10, then this will return me true because it compares two situations. First, the first one is it checks if the first number is greater than the other number. If that statement is true, it will return true. But if that is false, then it moves to another condition, which is equals to condition. In the similar way, we also have less than or equals to operator. If I write 10 is less than or equals to 10, this will again return true. We can also store the values in a variable and then we can compare using comparison operators. For example, if I create a variable called age and I store 18 in this, and if I create another variable and say result is equals to age is greater than 20. So here the age is 18. And if I write age is greater than 20, so this is a true statement. And if I print result here, it will return false. Sorry. Okay, so it will return false because we have age is equals to 18. And the result says age should be greater than 20. But the age is 18, which is not greater than 20, so it returns me false. Now what we are going to do in the next problem statement, we are going to create a program in which I will take two numbers input from the user and then we will apply each and every comparison operator. So firstly, let's create two variables, num1 and num2. We will take input from the user, int input, enter number 1. Similarly, enter number 2. Now we have two inputs from the user and now what we will do, we will apply each and every operator to these two numbers. Print. For the first operator, which is equals right, num1 is equals to num2. Second, we have the greater than operator. Right, num1 is greater than num2. Then we have less than operator. Hint. We also have less greater than or equals to operator, greater than or equals to. We write num1 is greater than or equals to num2. We have print less than equals to num1 is less than or equals to num2. And lastly, we have the not equals to operator. Num2. So this is how our program will looks like. We will let's press shift plus enter. Enter number 1. Say I write 5. Number 2, let's say we have 2. Shift enter. So the equals condition is false because 5 is obviously not equals to 2. The not equals to condition is true. Greater than, yes, 5 is greater than 2. So it return a true statement. Less than, false, which is opposite of greater than. Then greater than or equals to is also true and less than or equals to is false statement.
So we have now comparison operators work in Python. Every comparison gives us either true or false, and these Boolean values are the foundation of decision making. In the next practical section, we will use these comparison results inside our first if statements, where our programs will start making decisions based on the user input. In the previous practical session, we learned how comparison operators return either true or false values. But just getting true or false isn't very useful unless we can make decisions. That's exactly what the if statement does. It checks the condition, and if the condition is true, it executes that particular block of code. So let's understand with some practical programs. Firstly, we will write the program to check the age. For that, say we create a age variable and store 20 in that variable. Now, what I want my program to do, if the age is greater than 18, then I have to print you are eligible to vote. For that, we will start our if condition. Firstly, we will write if, then we will define our condition, which is age should be greater than or equals to 18. And then we will end this condition using colon. And after that, in the second line, after one tab indentation, we will write print you are eligible to vote. If I run this program, says our age is 20, it will print you are eligible to vote. But if my age is say 15 years, then it won't print anything because I haven't defined the else condition. Now moving to the second program, which is positive number. So what we are going to do, we are going to create a num variable and we will take input from the user. And then we will check if the number is a positive number or not. So in the if condition, I will write if number is greater than 0, then print positive number. For example, if I enter 2, if I enter 2, it prints positive number. So this is the second program. And now what we are going to do in the third program, that is uh, in the third program, we are going to check the password. For example, I define the password. Say my password, I will take input from the user, enter password. And in the if condition, I write if password is equals to Python 123, then print access granted. So if I run this code, if I write any other password, say I write 456, then it won't give me an output. But if I write the same password, this one, if I write Python 123 here, it will print access granted. So now we have written our decision making program using the if statement. Remember, an if block only executes when the condition is true. Otherwise, Python simply skips it. In the next practical session, we will learn about if else statement. Welcome back. In the previous section, we learned how the if statement works. We saw that when a condition is true, Python executes the code inside the if block. But when the condition is false, nothing happens. In many real-world applications, we want to handle both situations. For example, if you pass an exam, display pass. Otherwise, display fail. That's where the if-else statement comes in. So today we will be looking at the if-else statement in this particular section. For the very first program, we will create a variable called marks and we'll take input from the user. So the passing criteria is if a student gets more than 40 marks, we will display pass, otherwise we will display fail. So we will start with our if statement. If marks are greater than or equals to 40, then print pass. Else, else what we are going to do, we are going to print fail. So this is how our final code looks like. Shift plus enter, we will run the code and save. I write 50, then it prints pass. But if I write any number less than 40, say I write 30, it will display fail. And if I write 40, since it's greater than or equals to, it will return pass. Then we have a very traditional program with us, which is even or odd. So in this problem, what we are going to do, we will create a number variable and take input from the user. And if the number is even number, it will display even, otherwise it will display odd. So firstly, we will take a number input, enter the number. After taking our number as input, what we will do, we will start our if condition. And in this, we will define our condition, which is if number modulus 2 is equals to 0, that means the number is even. The modulus operator gives us remainder. So if I divide any even number with 2, it will give me 0 as a remainder. So if the remainder is 0, print even number, else print odd number. Now shift plus enter. For example, if I enter an odd number, say 5, it will return odd number. And if I write an even number, say 20, it will return even number. We can also check which of the two numbers is largest or smaller. For that, what we are going to do, we are going to create two variables for num1 and num2, and we will take input from the user as well. Similarly, we will take number2 input, enter number. Now, what we are going to do, in the if block, we will define our condition, which is if num1 is greater than num2, then print num1 is. We can also use f strings here. Say I say f string starts, and if then I will say num1 is greater than num2, else print num2 is greater than num1. Shift percent, you will run the programs. For the first number, I enter 5, and for the second number, I enter 2. So it says 5 is greater than 2, which is absolutely a true statement. So we are now done with the else statement here. In the next practical session, we will look at the else statement where we will handle multiple conditions such as grading system, traffic signal, and menu-driven programs. So this is a very common technique used in real-world software. In the previous section, we learned about if-else statement, which helps us make a decision between two possibilities. But in many real-world situations, we have more than two outcomes. Think about a grading system. A student can receive grade A, B, C, or T, or fail. We can't handle all these possibility only with if and else statement. That's why Python provides the elif statement. It allows us to check multiple conditions one after another. Let's understand this by writing some practical program. Firstly, we will create a program for grading. For that, I will define a variable called marks and I will take input from the user. Since these are marks, the input will be in int format only. After that, we are going to start our if statement. Firstly, I will define my first condition, which is if marks are greater than or equals to 90, then print grade A. After that, we will write elif. Elif marks are, we will define our second condition, which is if marks are greater than or equals to 75, print grade B. Elif marks are greater than or equals to 60, print grade C. And elif marks are greater than equals to 40, print grade D. And if none of them are true, print in the else statement, we will print fail. We'll run this code. Firstly, I will enter 95. So it returned grade A. Then we will write, say, 80, grade D. Then we will write 66, grade C, 33, sorry, 43, grade D, and 33 is fail. The next program which we are going to do is simple calculator. For that, we are going to take two inputs from the user, two numbers, num1, num2. After that, we are going to take our input as operator, input, enter, operation, which can be plus, minus, multiply, and divide. Now we will start our if-elif statements. If our operator is equals to plus, then print addition. which is equals to num1 plus num2. Elif operator is equals to minus print subtraction, which is equals to num1 minus num2. Elif operator equals to multiply print, which is equals to num1 star num2. And if operator is equals to division, then print divide num1 divided by num2. Now we will run the program. Say my first number is 5 and second number is 2, and I want to perform addition. So it returned me addition, which is equals to 7. Say I have my number is 52 and my second number is 2 and I want to perform division. So the answer is 26. So this is how we can make our working calculator. Now we know how to handle multiple conditions using the if statement. This is a technique we will frequently see in real world applications like grading systems, menu-driven programs, and traffic management systems. In the final practical section of today's lecture, we will learn about nested if statements.